Good morning, everyone. Welcome to this webinar series brought to you by SOA Software. Today, we have a very extremely interesting and relevant topic, which is API security, securing digital channels and mobile apps against hacks. As we have seen, there has been a widespread increase in adoption of APIs, but at the same time, we have been seeing over the last couple of years, there has been an increased surface area of threat that API exposes, which has been compromised by hackers. So today we are going to be talking about the basics of APIs, how to secure APIs, and API security in general. And I am Sachin Agarwal. I'm VP of Product Marketing at SOA Software. So before we jump into the webinar, a couple of housekeeping things. So we have a resource center at http://resource.soa.com. There are a ton of resources around API and SOA best practices. Do visit that URL. You'll see a lot of information out there. The webinar recording will be available at the URL over here, which is resource.com/resource/webinars. We'll also send out a mail with to all the attendees with the link to the recording. And do follow us on our social channels, which are on Facebook, LinkedIn, and at Twitter. There's a lot of information that we keep on posting on these channels. So do like us on one of these channels and you'll get a good flow of information from us. So jumping into what is an API. So hang on to the question about API security. I did want to spend the next 4 to 5 minutes just explaining what is an API and why is there an increased threat of from a security perspective with APIs specifically. So if you look at any large or even small enterprise, they have their applications, their products and services, which now they want to make available to their customers, to their partners, to their employees. And their partners, customers, and employees are accessing these applications and services through a vast variety of mediums. They're accessing obviously from desktops and web browsers, but now more and more they're accessing these products and services through mobile phones, through Internet of Things, through connected devices, cars, homes, or shopping e-commerce sites or e-commerce locations. So how do you as a company, as an enterprise, make your application and services available in a programmatic fashion to these devices and finally to your customer? And that essentially is by taking your applications, exposing them as APIs so that they can be consumed within all these different channels. And that essentially is an API. It's taking your products and services or part of your products and services, making them available in a programmatic interface so that they can be used by your so that they can be embedded in these devices. Another important aspect of APIs is that they're extremely open. The number of devices out there are increasing in an exponential fashion. You want to make them open so that a large set of open developers that are out there or your partners can take these APIs and build these applications, because you yourself as an enterprise will probably not be able to scale to suffice to all these different channels. So that is what is kind of leading to what we call as API economy, which is extending the reach of your business to reach all these different channels where exactly your customers are. So as a company, you expose your products and services and API and make them available to customers irrespective of where they're accessing it from tablet, web apps, gaming consoles, smartphones, connected devices like appliances or connected cars, websites, or partner applications. Now, as your applications are becoming more open, you're making them more open through APIs, and which is an essential thing that your business need to do. It's also exposing the surface area for attack. It's becoming, through programmatic interfaces, becoming much more easier for anybody with malicious intent to come in and compromise your API. So to understand that a little bit, let's look at how the digital channels have evolved over the last 25 to 30 years. So initially, I mean, if you go back to around 25 years in early 90s or mid 90s, the only way information was accessed was through primarily client server applications or web applications. So you had specific applications that were that had a client that was very tightly coupled with that application, with the database, with the backend. And there was no programmatic interface that that application exposed so that it could be consumed from any other medium. And so essentially, those applications were logged in by design. Also, there was the network isolation. Most of these were primarily within the intranet, or if available outside the intranet, outside the firewall, it was primarily through VPN. And there were a limited number of users, restricted to essentially employees within the firewall or outside the firewall. Then came web services. So late 90s, early 2000, the enterprises started to open up with web services and SOAP. And you started seeing obviously a lot of web applications, the internet revolution, and enterprises started to exposing their applications primarily to B2B and partner applications. And the security in this case was, in case of SOAP and web services, was actually quite extensive. It was based on SSL and TLS, it was certificate based, PKI based, and there were standards like WS security and WS trust. But these standards were extremely complex. They were heavyweight. It required a lot of processing both at the server side as well as the client side. And it was not easy to set up these, but they were quite secure and quite flexible also. But as you see now, then came the APIs somewhere around mid 2005, and they disrupted how and where the information was being accessed, which is essentially all the different channels that I just talked about. And to make your products and services available across all these channels, it was important that you made adoption really easy, because you as a company cannot kind of, most companies don't have the resources to surface their applications in all these channels. So they need to rely on a community of developer, make the API really easy. And also the mobile devices and social apps really don't understand some of the PKI and WS security aspects that work, that had kind of become a trend with SOAP and web services. So what does it take? I mean, so if you look at API security and to realize end-to-end security within API, there are a couple of things that you need to take into account. The first one is managing the user experience. Which is, a lot of these applications are being surfaced through mobile applications or social app, and you need to make the user experience of a customer or a user logging in really, really seamless, easy and seamless. The second is around securing the app itself, securing the social app or the mobile app. It might have some personally identifying information or health information, depending upon what kind of an app it is. So how do you secure that data that the app has in rest, at rest? Then the data that's flowing through the channel between the backend servers or the cloud and your mobile app. So you need to secure the channel, secure the message as it's flowing through the channel. You need to make it really, really easy. While you're making your app secure, you're making your channel secure, you still need to make it easy for a large community of developers out there to quickly access your API, get provision to an API so they can develop more apps. And then finally, you obviously do want to support your or secure your backend. You don't want your backend to be compromised. You don't want any hacker to compromise your API and get access to more than what you want. So there are a lot of things. The other question that we get a lot is, there are a lot of security solutions out there. So where does exactly API security, or if there's a place for a separate API security? So if you look at the landscape, uh, there are 3 or 4 categories, widely speaking, and there may be a lot more categories, but widely speaking, there are four categories. The first one is single sign-on. The single sign-on solutions essentially provide you a place where they manage the identity of users. So if you have a bunch of users, they manage who the users are, and they essentially control authentication authorization so that users don't have to remember multiple passwords or have multiple logins. That's the second one is a relatively new area that's primarily around mobile security or mobile app security, mostly focused on enterprise mobile apps, which is MDM, mobile device management, or mobile application management. And there are vendors like Mobileye and Good and AirWatch over there, which is primarily around how to provision enterprise apps, and if a device gets lost, and how do you remotely wipe off data from that device. And then there are a lot of other security vendors like firewall, advanced threat protection, VPN, backend security, perimeter security, and there's a bunch of vendors over there around Barracuda, Bluecoat, Checkpoint, FireEye, Juniper, Cisco. You have a bunch of security vendors over there. That's a wide area. But none of these vendors specifically, or none of these solution or areas specifically address risks around API. So with API, there are protocol-specific threats. APIs could be REST-based. I mean, API could also be SOAP or other new protocols. So there are some protocol-specific threats that you need to be they're intrinsic to the protocol that you're using. With APIs, there is key management. There's OAuth that needs to be taken care of. And then obviously there's monitoring and licensing and security token mediation. So these are some of the areas that I'm going to talk about next. And API security needs to be looked at. You need to be understand when you're designing an API. You need to be aware of all these aspects when you're designing and rolling out an API. So understanding API security. And to understand API security, let's first look at the entire API lifecycle, which is how do you design an API, how do you build an API, operate it, and roll it out. So essentially what you're doing is when you're taking out an API, there are API producers, which are the people who own the API. They're taking the existing products and services, and they're exposing as APIs to API consumers who can then kind of build apps or mobile apps or social apps. So various different steps that are included in terms of rolling out an API are the first one is you take your existing application services or maybe new applications or services that are sitting in the cloud or behind your firewall. Then you transform them into APIs, into REST-based APIs, and you secure them. So that's essentially where security comes in. You take your API and you publish them on a portal wherein developers can start coming in, and you start marketing your API, get developer adoption going on, help them build apps. There's OAuth mediation, then there's the monetization aspect. You might want to monetize your APIs. There are a lot of different business models around monetizing APIs. So these are some of the steps. Obviously, there's monitoring and there's analytics and there's API documentation in between. So let's now focus just on this first blue box over here, which is security. So what are the different things that you need to do from securing an API? The first thing that you need to do to secure an API is authenticate and authorize the user who is accessing the mobile app or any other app that you have created, whether it's a social app or other web app or maybe anything. So you need to authenticate the identity and authorize the access for the user itself, the end user. The second one, and probably it comes before the first one, is app key validation. So essentially the app developer, the developers who are developing these apps, you need to provision access to an API, to your API, to these developers. And for that, you need to provision an API key to them, and you need to license it. You need to restrict the access of these developers as to what specific aspects of your API they can access. The third one is message security, which is securing the data that's flowing in your API as it's passing through the internet or it's moving through the channel. The fourth one is around threat protection. So while you can secure your API with authentication authorization, you can secure with message security. There are a lot of hackers out there who are trying to compromise the vulnerabilities that are there in your APIs, in the client app, in the way the user is accessing, or in your backend. So there are a lot of threat protection capabilities that you need to build into your infrastructure. Some of those are around content filtering, which is you need to filter the content to make sure that no hacker is kind of put in SQL injection or JSON query attacks or virus attacks, and we'll talk about that a little bit. And then there is rate limiting or monitoring, which is you need to monitor how your APIs are being used, from where they're being used. You have to go and manage the number of operations that are being called by a specific app or a specific user, or from which reason they are being called. So let's look at each of these in a little more detail. So the first one is authentication and authorization, which is essentially single sign-on. Control and restrict access to your APIs based on the user who's accessing it. So the end user, the consumer who's accessing the app, you need to first authenticate, which is validate the identity of that user. And then second, authorize whether that user has access to the data or resources that he or she is trying to access. So over here with authentication and authorization, there are a couple of aspects. One is there are a lot of protocols out there that your API might need to support. The most popular one is OAuth, and we'll talk a little bit more about OAuth, but there's OpenID, there's OpenID Connect, which is a combination of OpenID and OAuth. There's SAML, there's LDAP, there's a bunch of more. So your API, essentially, an API infrastructure, you might need to understand or mediate between all these different token types. And then finally, it needs to integrate with some single sign-on system. In some cases, consumer-facing apps, you might be integrating with a social login, which is you might be authenticating a user against Facebook login or Google Plus login or Twitter or something like that. Or in case if you have an enterprise app or a B2C app where the enterprise itself is storing the credentials, then you need to authenticate and authorize against a single sign-on system, which might be provided by one of the vendors like IBM, Oracle, Okta, CA, or Windows Active Directory. So those are the aspects just from authentication and authorization perspective. Let's look a little bit more about OAuth, because the OAuth is the most popular mechanism for authentication and authorization. And if you look at OAuth, why it is so popular for APIs is because OAuth lets a person, like the user, delegate constrained access from one app to another. So what does that mean? So in this case, if you look at the user or the resource owner who has a resource on the right over here in the resource server. So this may be, for instance, Facebook. The user is user who has an account with Facebook. You might want to give access to a mobile app to some information that's in Facebook. So you want some other app to access your Facebook account and access some information on behalf of you from Facebook. But you want to give that app restricted access. So OAuth allows you essentially to give restricted access to the client app without ever divulging his user ID and password, his credential to the client app. So the user ID and password mediation happens directly between the resource owner and the resource server, and the client app just gets authorization token, which it can use uh, to get access to the user's resources. So let's look at it in practice. What does the Auth Flow? This is a very simple Auth Flow. So Hootsuite is an app that essentially allows marketers like me to post onto multiple channels, multiple social channels, so LinkedIn, Twitter, Facebook, and things like that. So from this, so Hootsuite really needs access to my Facebook, Twitter, and Google Plus channels. So what I can do is I can sign in over here with Twitter, and when I click Twitter, it essentially takes me to a Twitter site wherein I, as an user, am directly working with Twitter, but giving but authorizing Hootsuite with authorization scopes, which is over here. You can specify all the different authorization scopes that you are providing Hootsuite on behalf of yourself. Your username and password is directly going to Twitter. Hootsuite doesn't get access to your. And once you authorize the app, Hootsuite gets an authorization token, which it can use to access my information in Twitter and can post information on Twitter and things like that. So that essentially is OAuth. But OAuth, managing OAuth is extremely, extremely complex. There are a couple of versions: OAuth 1.0, 1.1a, and then now OAuth 2.0. And all of these versions is extremely difficult, both for the client and at the backend. There are a lot of things that you need to do in order to configure OAuth both at the client side and at the backend. For the clients, you need to provision. You provision access to OAuth. You need to have approval flow, which is what kind of like the flow that we just saw for Hootsuite and Twitter, and define the authorization scopes. In some cases, you might want to, in the last case that you saw, the authorization scope were not configurable. In some cases, you want those to be configurable by the user themselves. Then on the server side, you need to have identity integration, token validation, or token validation. You might want to have token issue and token refresh, which is the authorization token that is issued to Hootsuite that you might want to get refreshed over a period of time. This token mediation, which is you as a client have OAuth and you might want to do token mediation across SAML and LDAP. There's obviously monitoring, policy management, API proxying, reporting and analytics, all of that which goes into OAuth. So OAuth can get really, really hard if you try to do it yourself, but it's also extremely important to understand all these aspects of OAuth to keep your service and API secure. So after authentication, authorization, and OAuth, which is part of authentication authorization, the next step is licensing. So authentication authorization is primarily about validating the end user who's accessing the app or the API. Licensing is more about validating access for the app itself. So whether the app has access to your API and what kind of access does it have to your API. And it essentially lets you restrict the scope of what the app can access. There are two aspects of licensing. One is the monetization aspect, so you can restrict the scope of what an app can access and monetize it differently. But also there's a big security aspect of it. So depending upon who the partner is or who the developer is, what's the maturity level of the developer, what's the credibility level of the developer, you might want to restrict the access of what that API, that app can access. So licenses can control OAuth authorization scopes. They can they can control the API scopes, what operations you can perform on that API. They can also control quota policies. And just from a usability aspect, you can use licenses to improve document visibility. In some cases, your APIs might be pretty large. I mean, in the sense that they might have a lot of operations. But based on licensing, you can create dynamic documentation. So a developer just sees documentation with respect to whatever he or she is licensed to access. So that's licensing. The next one is how do you secure the data that's flowing between the API client and the API backend. So that's message security. And in case of API, that could also mean HTTP parameter security. So one of the things that comes into mind with HTTP parameter security is API key. So as part of licensing, when you give an API developer a license, they get an API key and the app gets an ID. The key can be compromised. If some other developer gets access to a key, they can probably try to access the same API. So it's not a good practice in general to pass API key in your HTTP parameter. There are practices like you can obfuscate that my key with the use of HMAC, which is hash-based message authentication code. and you can protect your key that way in terms of it will not be, nobody will be able to spoof it. The second one is message security, just protecting the data that's flowing between the client app and the backend. And there are two ways in which you can do it. So if you have an API that has JSON, then you essentially implement HTTPS, which is TLS or SSL security, and protect the entire channel so that they can't access any part of that message. If your payload has XML, then you can use WS security to encrypt just specific aspects of your message. But in that case, you need your client to do a little bit more processing in terms of they should know which part of the messages has been encrypted, and they should be able to decrypt it. So it needs a little bit heavier weight client. But those are things, and then obviously you need the client to know what policies are there and have access to those protection policies. So that's message and parameter security. The next is threat protection. And that's a very, very important aspect of your security, which is you need to build into your API infrastructure provisions to protect your service from getting hacked. So there's things like distributed denial of service, where somebody can start and use a wide variety of servers to just bombard your gateway or your service. So how do you prevent somebody from taking down your service by just doing denial of service attacks? Then there's injection attacks. There are things like SQL query attack, which were prevalent in the web world, web applications. A lot of SQL injection queries have been used to compromise the backends, and their APIs are not different. APIs could be used as well. There are things like JavaScript, XPath, XQuery injection attacks also. So they can use malformed XPath queries, XQuery to get access to data that you probably don't want anybody to get access to, and they can compromise your backend. There are other things around cross-site scripting, network address, and range blacklist and whitelist. So you can have a blacklist and whitelist of which IP addresses or network addresses can access your app. And then HTTP parameter stuffing, which is actually a lot of hackers have now started overloading the parameters on HTTP, though at which kind of, if you don't take the necessary steps, they can confuse your server, they can lead to buffer overflows, and then that can lead to compromising your backend. So you need to put in some measures out there to protect against HTTP parameter stuffing as well. The next one is around content filtering. It's in the same line of threat protection, but a slightly different category, which is the content itself that's coming in the message of your API. You need to validate it. You need to validate it against viruses. So if you have some attachments that coming through your API, being able to scan it for binary content and integrate with virus engines and scan for viruses. Also check for message consistency and data structure consistency. So make sure that the XML message and the JSON data structures comply and are comply to what has been defined in the API definition. And finally is quota management and rate limiting. So depending upon how your API is being used, you need to monitor it extremely closely. You need to go and manage where your API is getting access from, how many operations are being accessed. You need to go and monitor any anomalies. You want to control quality of service, which is if a particular API, if you look at what happened recently in the Snapchat hack, over December, the Snapchat API had been hacked. And essentially what happened with Snapchat was through a single app, the hacker was able to request all the data for 300 million users, I think for 300 million users through one API, through one operation or multiple operations through that same API, they were able to, in a small period of time, download all the 300 million records. Had they had put some rate limiting and monitoring over there, with licensing in place, they would have been able to prevent that. So they could apply controls. You can apply controls on various different aspects over here with rate limiting and quota management, which is based on context, which is from where it is being accessed, based on affinity, based on segmentation, based on licenses. So you need to have quota management and rate limiting. Over here, you also, what you can do is you can generate a lot of logs and you can pass these logs to advanced threat protection systems. So there are a lot of systems like FireEye and other cyber threat protection systems who are constantly monitoring attacks. And if you pass on their logs to them, they'll do a big data analysis and they'll give back you some relevant information of potential threat metrics. So we've discussed a lot of things around security, API security, and these are things that you need to take care from an API perspective. They're very, very specific to API. But from a SOA software perspective, we do provide an API gateway, and the gateway essentially takes care of all the security aspects that we just discussed. So it's a single component, a single product, and it takes care of security, authentication, protection, identity and access management, mediation, paging, and a lot of other capabilities. So it's a single point which can be deployed both on the cloud as well as on premise. And it takes care of almost everything that we discussed here from an API security perspective, making the life of an enterprise who's planning to roll out an API much more easier. If you look at the entire API platform, there are a couple of things that you might want to do. Starting from the bottom, you want to manage the lifecycle, which is how you plan, build, design, run, and operate an API. So manage the entire lifecycle, versioning included. The second one is you want to have gateway services, the things that we talked about, mostly around security and monitoring, but also service integration, which is orchestration and mediation and transformation. And then finally, developer engagement and do analytics on your APIs. And for that, you need an API portal or a community manager. So these are some of the aspects of the SOA software API platform across 3 different products: Lifecycle Manager, API Gateway, and Community Manager. And here is just this is just a flexible deployment model that I talked about, which is it's available both on the cloud as well as on premise as well as hybrid. And this is just a short list of all the capabilities that the platform provides. So with this, what I will do is I'll open it up for questions. So if you have any questions, there's a chat window. Please post your questions over there and I will answer your questions. Let me see what are the questions over here in the chat window. Okay. So the first question is, if you are trying to ask, we were just trying to unmute, so you'll be unmuted so you can ask. In the meantime, I am getting questions. Is for OAuth or in OAuth, where is the approval flow enforced? So in this example, Hootsuite doesn't access more account info than it claims to. So that's a good question. So the question is essentially how does OAuth enforce restrictions? So there are things like OAuth scopes, and OAuth scopes essentially define what you can access, what that API or what that application or the client application that you're. So OAuth scopes are defined in the policies, and they can be defined as part of your key. So you can define and attach these policies and make them as part of your licenses. So in this case, in Hootsuite, depending upon the type of key that is a license key or the license that is issued to Hootsuite, that will have the scopes, OAuth scopes defined, and that restricts the information. The second question that I have is, I have a SOAP service that is being transformed to REST-based API. Where do I apply authentication and authorization policies? So that's a good question. So if you have a SOAP service that is being transformed to REST, so you could essentially apply authentication both at the SOAP service or the REST service. And from our perspective, what we see is you essentially need one infrastructure which applies policy across your SOAP infrastructure as well as REST-based APIs. So if you do that, you essentially have a single policy, and it doesn't matter where you enforce that policy because the pipeline is the same pipeline. You can decide to enforce either at the REST level or at the API level, but the same policy. If you have different infrastructures for SOAP and REST, you essentially would either have to go and apply this policy at different levels and manage it and ensure that it's being applied, and it can get a little complex. But it's a good question. I mean, if you have if you are transforming the service, where do you apply your authentication authorization? Next question is, how does HMAC help in securing HTTP parameter key token? Is obfuscation enough to prevent somebody else from using the same key? So HMAC, essentially what HMAC does is it creates a hash. It's essentially an hash. It creates an hash, base 64 or RSA or a SHA based hash, depending upon whatever you do. And it your API key is hashed in the parameter. And then when it goes to the server, based on your app ID, it'll unhash it and it'll know where exactly. It'll authenticate the app based on the app ID, and only the client and the server will be able to go and see the key. So HMAC essentially is more than just simple obfuscation. I'm getting a lot of questions. I'm just looking at again which one should I pick up. So the next one is, why should I care for PCI compliance if I don't have credit card information in my API? That's again a good question. So PCI compliance, PCI DSS 2.01, it's primarily for the financial industry and for credit card information. But what it does more than that is, it is, as a company or when it goes through PCI compliance, it's going through a compliance where somebody comes in, an auditor comes in and takes an assessment of their entire infrastructure. And it thinks around just not securing the PCI or the credit card information or personal identifying information. That same infrastructure can be applicable to any information that's flowing. It also is around how solid your infrastructure is in terms of HA, in terms of backup and recovery, in terms of scalability, in terms of audit and logging in order of compliance. So there are a lot of different aspects which are not really applicable to just the credit card information or the credit card industry. It just ensures that your infrastructure is solid and hardened and can do a lot of different things. So I'll take one more question because we're running out of time, but I'm getting a lot of questions over here. So what we will also do is we'll do a blog post wherein we'll answer all the rest of the questions. So let me just pick one more question over here, which is, okay, API security. So how do I handle, so the message security, in terms of message security, you have HTTPS or TLS or SSL that you can use to protect the messages, but how do you protect data at rest within the mobile app? And that is something actually that's very interesting. So data at rest, which is in the mobile app itself, the API infrastructure in general doesn't provide you any specific mechanism in terms of how to protect data at rest, because that's a purview of the mobile app developer itself or the device on which it is. For enterprise apps, there are MDM and MAM solutions, which is mobile device management, which create containerized or containers that can secure the service. But it's primarily the prerogative of the app or the container that's in the app or the mobile device itself on how you secure that data at rest. So with this, so the last one is actually, will the shares will be available? And can I share my email address? So yes, these slides will be available. They'll be posted on a resource center. The recording will be available on our resource center as well. We'll send an email to everybody who attended this. Uh, they can get access to all this information, as well as you can directly contact me. My email ID is sachin.agarwal, SACHIN dot Agarwal, AGARWAL at SOA.com. So thank you for attending, and hopefully you found it useful. And we will see you the next time in our next webinar. Thank you, everyone.